All right, so I'm going over page 8 in the notes packet. See my video where I went through page 7 if you missed that. Otherwise, let's go ahead and get started on the practice. So, first one, we have a binomial case. We're going to start by trying to simplify anything that we can. You see right away that there's nothing we can simplify, right? We can't divide 3 or 2, and we can't simplify square root of 5. So let's go ahead and rationalize by multiplying by the square root of 5 over the square root of 5. On the top, we would get 3 square root of 5 divided by, and then on the bottom, we would have 2 times, and the square root of 5 times the square root of 5, that's like the square root of 25, so that just becomes 5. Right? If we have the square root of the same number multiplied by each other, it just becomes that number. Putting it all together, 3 root 5 on the top, 10 on the bottom. That's as simplified as we can get, right? There's nothing here that we can cancel. This is fully simplified. Over here, whenever we have a radical with a fraction inside, remember we can always break that up into 2 separate radicals, right? Square root of 8/15 is equal to the square root of 8 divided by the square root of 15. We can always do that. All right, now we want to simplify anything that we can. Looking at this, square root 15, we can't simplify that, right? If we try and break that down, we're going to get 3 times 5. That's not a pair, right? There's not a pair there, so we can't simplify that any further. But the square root of 2 times 2 times 2, which if you notice is equal to 8. Well, we have a pair of 2's, so you can bring that outside. So the square root of 8 here turns into 2 times the square root of 2. So square root of 15 on the bottom. Can't simplify either of these, can't simplify any of the numbers, so let's multiply by the square root of 15 to rationalize the denominator. On the top, we get 2, and now the 2 is in a radical, the 15 is in a radical, so we can multiply these two, right? You can't multiply numbers outside the radical with numbers inside the radical, but you can multiply two numbers that are inside the radical. You get root 30. And then if we have the square root of 15 times the square root of 15, well, just as we were doing before, that becomes 15, and there's your answer. Now, this is one where it's really important to simplify before you rationalize the denominator. And the first thing I'm going to see here, square root of 270, that can definitely be simplified. So let's get into that. We go 30 and 9, 3 and 3, 3 and 10, and 2 and 5. That becomes the square root, 2 times 3 times 3 times 3 times 5. See that we have a pair of 3's here, so you can pull that out, and it'd be 3 times the square root of 2 times 3 times 5, which is 30. All right. Oh, well, hopefully my iPad makes it to the end of the video. It should. We substitute that in and have 20 root 30 over 4 root 3. And let's pause here. Actually, wait. We can do one more thing. Here, I'm going to simplify the number out in front, right? We have 20 over 4. If that were on its own, 20 over 4, then that would become 5. So, and again, 5, that's like 5 over 1, right? So we would have a 5 in the numerator and a 1 in the denominator when we do that division. And we write this 5 root 30 over root 3, right? We've done that, essentially. I'm going to pause here because we're going to do this two separate ways. The first one is the way that we've been learning, right? Just multiply square root of 3 over square root of 3. That would then be 5 times the square root of 90 over 3. The square root of 90, well, that's going to become, we can think of that like the square root of 9 times the square root of 10, or 3 root 10, right? Using our perfect squares method that, not many of you are fond of, but still, if you do it the prime factorization way, you'll get the same answer. So square root of 90, that becomes 3 root 10. So this would become 5 times 3 root 10 over 3. And if we have a 3 on the numerator and a 3 on the denominator, well, those divide down to 1, and our final answer is 5 root 10. I said there was a different way to do it. So let's backtrack to here. And going back to this problem, notice how our first step was to break it up into two different radicals, right? The square root of 8 over the square root of 15. Well, we have the 5 times the square root of 30 over the square root of 3. Just as we broke this up into two different radicals, we can combine these two into a single radical. 5 times the square root of 30 over 3. 30 over 3 is just 10, so there's 5 root 10. Right, we can use any, as long as we are applying the properties in the right way, we can apply them in any order, and sometimes we can take shortcuts to get to our answer more quickly. Now, this one is kind of similar in that we can break this up into the square root of 18 over the square root of 30, and we can go from there, right? We can just do this step, but we can also simplify first. So if we do 18 divided by 30, I see that 6 goes into both of those. So if I do 18 divided by 6, I would get 3. And if I get 18 divided by, or if I get 30 divided by 6, I would get 5. So the square root of 18 over 5 has to be equal to the square root of 3 over 5, right? We can do this in really any order. So as long as we're doing valid operations, we can do it that way. Now, we know that that's equal to the square root of 3 over the square root of 5. Right? We can do that, we can do that. And now we can just multiply the top and the bottom by the square root of 5. Square root of 3 times the square root of 5, that's both in the radical, so we can turn that into the square root of 15. Square root of 5 times the square root of 5 becomes 5. Okay. Now moving on here. There's a really big shortcut if you guys remember what we were doing up here. Take a moment, see if you see that. But I'm still going to do it this way. Multiply by the square root of 3 over the square root of 3. Square root of 6 and square root of 3, that'd be 18. We would have 4 times 3 on the denominator, right? Because 3 times 3, or square root of 3, square root of 3 gives us 3. We bring a 4 over, so you would have root 18 over 12. Root 18, break that up into root 9, root 2. Again, do the prime factorization if you have to. You get 3 root 2. And so then this would become, if the square root of 18 is equal to 3 root 2, then the square root of 18 over 12 is equal to 3 root 2 over 12. And we can, if we had 3/12, we would simplify that to 1/4. So 3 over 12 would become just 1 over 4, or root 2 over 4. Now, what I was saying about there being a really big shortcut here is if you started with this and you just combined the root 6 and the root 3 into a single radical, you would still have the 4 in the denominator, but then we would have a radical 6 divided by 3, right? That's a valid operation. Root 6 divided by root 3 becomes root 6 over 3. We're still dividing by 4, the same as multiplying by 1/4. 6 divided by 3 is 2, so we're going to have a root 2, still multiplying by 1/4, or dividing by 4 is your answer. Kind of without any work, you can do it. All right, so now we're into the conjugate case, right? The binomial case. We have two things going on. And as we saw in class, that means we need to multiply by the conjugate. The conjugate being an expression that has the same two terms, but with the opposite sign in the middle. So this would be 10 plus root 3, and this would be 10 plus root 3. So we're going to distribute here, distribute here. So in the numerator, we would have 80 plus 8 root 3. Again, remembering that we can't combine this, right? It's imagine like we had 8 times 10 plus x. That would be 80 plus 8x. And the same thing holds if we have a radical there. All right. In the denominator, we need to double distribute. So I'm going to do this one the first way that we learned. I'll do the later ones in maybe a slightly shorter or slightly different way. So if we double distribute, we're going to start by doing 10 times this entire second expression, right? 10 times 10 plus the square root of 3. And then we're going to subtract the square root of 3, right? So we're essentially multiplying this 10 by the entire second term, and then we're going to also distribute the negative 3 to the entire second term. Right, you need to watch out. See, this term is the same as it is there and there. You're just multiplying it by this first and then this. And then we can distribute again, and that would be 80 plus 8 root 3, keeping the numerator the same. You do this and that. 10 times 10 is 100. 10 times root 3 is plus 10 root 3. Minus root 3 times 10, well, that's minus 10 root 3, right? We usually write the number before the radical. And then minus root 3 times a positive 3, that's minus 3. If you're not sure about that, think about it as root 3 times root 3 is root 9 or just 3. You know, root 3 times root 3 is 3, but one of them's negative, so the answer would be negative. And what we see here is we have a positive 10 root 3 and a minus 10 root 3. But again, if we had 10x minus 10x, you would say that's 0 right away. Well, it's no different if it's a radical, right? 10 root 3 minus 10 root 3, 0. Cancel each other out. So we have 80 plus 8 root 3 over what's left in the denominator, 103 minus 3. So 100 minus 3 is 97. Great. All right. So what's the difference here? Well, now we have two radicals, but the process still holds, right? If we multiply by the conjugate, we would still want to do root 3 plus root 15. Notice how this is still the conjugate, right? The square root of 3, square root of 3, square root of 15, square root of 15. This is negative, this is positive. Even though they're both radicals, it's still the conjugate, right? The process still works. So root 3 plus root 15. All right. Starting with our numerator, we go there and there. And again, we can't multiply 5 times 3 here, right? We can't say that this is root 15 because 5 is a whole number and root 3 is a radical. If you saw that notification from my program director, I'll take that as a moment to put on Do Not Disturb. Sometimes I forget to do that, and I have to record the video, re-record the video. Okay, so we can't turn that into the square root of 15, but we can turn that into 5 times the square root of 3 plus 5 times the square root of 15. And we can do that. Now, in the denominator, we're going to have, let's do it this way. I'll take that as a moment actually to break this down further for anyone who that might benefit. If we do this, we do this. Right, so we've dragged essentially this denominator, and we're going to look at it for a moment over here. We'll recombine it down there at the end, but I want to kind of dissect this a little bit more slowly. So the analogy that we went over in class is imagine if this set of parentheses were a car driving to a party, and this set of parentheses were a car driving to the party. These two people are driving together, so when they get to the party, this root 3 has to say hi to this root 3 and to this root 15. This negative root 15 needs to say hi to this 3 and this negative root 15. These two people do not need to say hi to each other, and these two people do not need to say hi to each other because they drove together, right? Two separate cars. But it would be really rude if this root 3 only said hi to this root 3 and didn't also stop by this root 15. And same thing with this root 15, right? They would need to say hi to everyone else at the party. It would be rude not to. So what would we get? Well, root 3 times root 3, that would be 3. Root 3 times root 15, that would be the square root of 45, and they're both positive. Negative 15 root 3 times positive root 3, well, that would be yeah, that'd be minus the square root of 45. And then the negative root 15 times positive root 15 would be negative 15. All right, so down here, so remember, we took this denominator, brought it over here, kind of multiplied it this way. And if you do it the other way, right, if you double distribute, you should get the same answer. I'm not going to do that here, but you should. And we can see that this would be equal to 3 plus the square root of 45 minus the square root of 45 minus 15. Positive square root of 45 minus square root of 45, that's going to cancel out. 5 square root of 3 plus 5 square roots of 15 over 3 minus 15, that's minus 12. Now, if you look over here, you may notice that this looks a little bit different. But those are actually the same thing. It just, we do typically move the negative sign out of the denominator, right? We want the negative sign on the top. The value is equivalent, but this is kind of the more conventional way to write it. So to do that, we would just multiply the top and the bottom. So let me do that on the other side so it's clearer to see. We're going to multiply the top and the bottom by negative 1. On the numerator, negative 1 times 5 root 3, that's negative 5 root 3. Negative 1 times 5 root 15, well, that's negative 1, 5 root 15. In the denominator, negative 1 times negative 12, that's positive 12. And there's your answer. All right, how many more of these do we got? 2, and then the bonus question. Cool. Okay. So I'm going to multiply by the conjugate again. Negative 3 minus the square root of 3. Negative 3 minus the square root of 3. You want to keep the terms here the same, right? This is negative, so you want to keep it negative and just switch this one. Starting in the numerator, and go there, there. So it'd be negative 3 root 2. Again, typically write the number first. And then minus the square root of 6. And in the denominator, well, we're going to do 3 times negative 3 times negative 3 is positive 9. Negative 3 times negative 3 root 3 is plus 3 root 3. Root 3 times negative 3 is negative 3 root 3. And then positive root 3 times negative root 3 is negative 3. Plus 3 root 3 minus 3 root 3 cancels out. And we're left with negative 3 root 2 minus root 6 over 9 minus 6 minus 3, which is 6. All right. Then can we simplify the square root of 35? I don't think we can. So let's do our conjugate. Square root of 35 plus square root of 5 over square root of 35 plus square root of 5. All right. Starting with our numerator, we would get 9 root 35 plus 9 root 5 over 35 times 35, or root 35 times root 35. Can give you 35. Root 35 times root 5, that's going to give you positive square root 175. Double check me if you don't believe me. I apologize if I'm wrong. Minus 175 from, so the first one comes from when we do this times that, and the second one comes from this times that. So when we do it here, it's positive. When we do it here, it's negative. And then the final thing we have to do is just negative 5 root 5. That would be minus 5. And then we would get 9 square root of 35 plus 9 square roots of 5 over 30. And at this point, you might be tempted to be done. But we can simplify it further because we have this number, and this number that are all divisible by 3, right? As long as every term in here can be divided by the same number, then we can simplify it. So we're going to divide everything by 3. If we divide 9 by 3, we get 3 root 35, right? And when I say everything, I mean all the terms, but we're knowing, right? That's knowing we can't divide this root 35 by 3 because this isn't a radical, right? We're dividing everything by 3, not square root of 3, so we can only change the numbers, not the radicals. So that'd be 3 square root 35 plus 3 root 5 over 10. And importantly, if we had something a little bit different, right? Let's say that we had 2 root 2 plus root 3 divided by 4, you might be tempted to do this. That would be wrong. You don't want to do that. Because in order to reduce something like this, right, where you have addition or subtraction, every term, all 3 terms, need to be able to be divided. So we can divide these 2 by 2, but we can't divide this one by 2. So we would leave it like this. All right, just pointing that out. That's a very common mistake. Oh, cool. That's all of the conjugate problems. Now we just get to do the challenge. So which of the following expressions is equal to x squared minus 5? Well, the easiest way to do this type of problem is let's just start to expand these answer choices and figure out which one of them is going to give us this. So if we look at the first one, x plus root 5 times x plus root 5, well, we're going to do x times x squared, plus x times root 5. And this one, we're going to do x root 5 plus root 5 times x, so plus another x root 5, and root 5 times root 5 plus 5. And this one is a little bit tricky, right? If we have x root 5 and we have another x root 5, what do we do with that? Well, we have one x root 5 plus another x root 5. We're going to get x squared plus 2x root 5 plus 5. Actually, take this, slide it up there. Do that. All right, let's try this one. X minus root 5 times x plus root 5. And that gives us x squared plus root 5. Oh, whoa, I'm gonna have myself. 2 minus root 5. X squared minus x root 5 minus x root 5 plus 5. X squared minus 2x root 5 plus 5. All right. And then finally here, I guess, and at this point, right, I guess pause. We're trying to get something equal to this. So we do all this out, we get this. We can see that this is not equal to that. We see that this is not equal to that. So we're evaluating these expressions. We're trying to get something that looks like that. So if we do this one, we get x squared plus x root 5 minus x root 5. And then we would have, so that came from 1, 2, and 3. And then our final one is root 5 times negative root 5. That would be just negative 5. So then we would have positive x root 5 minus x root 5. That cancel it out. We'd just be left with x squared minus 5, which you might notice is exactly what we are looking for. So C is your answer. All right, this video is long enough.